All right. Very good morning. Can you hear me?
Yes, sir. Good morning,
Good
sir.
morning, sir.
Good morning.
Yes, sir. Good morning.
Good morning.
Assalamualaikum. Good morning, sir.
Welcome, Islam. Good morning. All right. I hope that all of you are doing well, and we are expecting a more number today as comparing with the first class. And again, I'm having two users. So one, you could find my video, and another one, you could find the audio from here. Okay. And already the course outline is already on there in Google Classroom. I believe that all of you have got it. And do you have any concern about the course outline? You can write down there in the classroom about any query, or maybe you can discuss. So we said like we are going to start today about the first preliminary discussion for the computer graphics, and we will try to have some interactive sessions so that after the class that what actually you have understood so far that we could check. And again we will try to have a recording session for your every classes, so that I have multiple sections, so that any one of the section will be taken for recordings, and within 1 or 2 days that recording it will be available to your Google Classroom as well. Okay, so let us start with the computer graphics. On other day we discussed something about what do you understand by graphics, or maybe this course, what kind of actually topics could be included. We also discussed about what could be our assessment process. We said about the quiz, the assignment, the project, and as well the exams, that how the exams could be taken. And if it is online based, if we continue up to the end, then maybe it will be the same process that you had, but it's still beforehand the exam, that we can actually discuss about the content, material, and the processing again. There are chances for the oral exam if it is on the online. If it is not, maybe on campus, then maybe we can move on to the conventional exam process that you have done maybe earlier. Okay, for the computer graphics, as we all know, this is actually saying about the definition, very bookish definition, that what actually the computer graphics is. And I believe that if anyone asks you that what actually do you mean by computer graphics at any level, that would be a concern. Like any level means actually a schoolboy also can ask you, and you can make them understand that what actually the computer graphics is. That kind of concept you should have, and that is actually our prime motive, that after the discussion, that much level of the understanding it should be for computer graphics. So you can see that last class also someone said that computer graphics is an art. Now it is an art of drawing pictures and lines, charts, etc. using computer. So why they are using actually the word art here? And you can see that you must need actually some programming, some kind of activity for the computing, which will give you the instruction for drawing these certain things like pictures or images. Now, when and how we can use the word art? Can anyone tell that on basis of what actually we are using this word art?
When you actually draw something.
Then they could have said that computer graphics is actually drawing picture, line, charts, etc., and so on. Why it made actually some kind of a specialty of art of drawing?
Sir, creativity. Further, we can call
creativity, right? Yes, and the creativity, if you try to emphasize that, what do you mean by creativity? What is the speciality of the creativity? You are creating something
new, sir.
There's something new.
something new. You see that if it is coming or happening something new, then what do you need? We need actually imagination, isn't it?
Yes, sir.
Yes, sir.
So that's actually the important thing, because it's very difficult to find something new as long as it is coming maybe for the first time in your brain. So why it is saying that graphics for computer, that it is an art of drawing? Because you are certainly creating something through your imagination, through your illusion, and you can do it by doing the programming, so that the instruction you're giving to computer on your own. So it is not like any specific thing only that can be done. It can be done actually in infinite number of pattern, or infinite number of actually the way that you can think. So that's why it says the art of drawing. And that's why whatever is not possible in real life, that actually people do the visual effect, right? That's the animation and visual effect. Very charming term actually for movies, for games, and so on, as you can see. And that is very expensive, as you know, that the animated movies are very expensive. So that you can understand that drawing these pictures, or maybe images, or maybe objects, models, and so these things in visual effects, those are not very easy. So you also need actually very complex programming for it. So if we go for a more technical way to understand, that computer graphics is made up of number of pixels. Okay, so pixel, we all know what are they. Even if you go for any people is not educated, even if you ask them, they are more or less now actually familiar with this term, isn't it? Pixel. How they are familiar? Because all of them are using maybe a phone with camera. Those people actually have some idea about pixel to understand their actually capability of the taking pictures with the camera. So what actually the pixel is, in simple way to understand? What do you think? It's been written here. It's the smallest graphical picture or unit represented on the computer screen. So in the computer screen, the smallest unit, that's it's saying, so that we all know that it's coming like small boxes, right? Those are actually the pixels. So we will focus in many part of our discussion coming on, where you will gonna actually find out the pixel, even that how to identify the pixel on the screen and so on. So that's made of, actually any image is made of actually huge number of pixel, and the pixel, you do define that pixel. On basis of that, you can actually create a picture. So graphics, computer graphics especially, as you see, that graphics is that word come from the graph, right? And the graph is actually what? When we come across this term graph in mathematics, that time there was no actually digital screen even, that how do you think about the graphics in there? So from that graph concern, that actually whenever it has been digitalized actually in the screen, so that the term graphics, then it comes. And whenever it is related with computer, then actually it is coming about the instruction, and then it is coming about the programming. Okay. So the definition of computer graphics is that the visual representation and manipulation of pictorial data by a computer. Now it is more like in computing way that we are trying to define, because we are talking about computer graphics, not other graphics. So whenever we are saying that computer graphics, it is a visual representation. As you can see that we are representing what in visually, some kind of data, which we are calling the pictorial data, right? And this is actually, we are representing as well as we are manipulating. Manipulating is actually we are editing. So that think about any video game at the same moment that you are actually as well changing the image through your commands, right? So that's actually, again, we can say in a computer graphics, or maybe we can say that graphics are actually the pictures and movies created using the computers, usually referring to the image data that we said another way, pictorial data created by the computer, specifically with help from specialized graphic hardware and software. You see that now it is more emphasized now. We say it always like with the help of programming or maybe with the help of computer activity. Now what actually you need to discuss about the graphic hardware and software, some component for the computing, especially for the graphical activity and as well as your programming, so that those two components you can use for actually showing the image data in your computer, so that you can actually generate the image as a picture or maybe a moving picture or movies, right? So that's actually the computer graphics. So I think in different angle that we try to define the computer graphics, so that whenever we are talking about huge number of pixels, in one way that we are discussing small pixels, they are actually creating an image on the screen, in computer screen, especially that we are calling computer graphics, or we are calling it is a kind of activity of representing the visual data, visually representing the pictorial data or picture data or image data, and also actually change it. So that's actually the activity of computer graphics. But we must need the help of the graphic specialized hardware and software. Okay. So I believe that at any level of your audience, you can actually explain the computer graphics. Do you have any question or concern here? Anyone have any question or concern here?
Sir, does a pixel represent a dot per inch?
A dot per inch. That's dot is actually just for your understanding. Okay. So pixel could be defined according to actually, yes, according to actually, you see that a vertical and actually horizontal line will create actually small boxes, and that could be changed screen to screen. Okay, and even the image to image, you see that images size, they are related also with size, they have a relationship with that, with the memory as well. So there are further more understanding about pixel you're gonna have, but at this moment you just consider that if you have a image on your screen, entire image, that a screen is actually divided into actually small boxes. Okay, and those small boxes are called the pixel. That's why we call the picture element. Okay.
All right, sir.
It could be defined in different unit in different pattern. Okay. If we consider, think about in a different perspective, you just understand. You live in say like sector 9 in Uttara. Now, how you can actually identify that location? We call it like that is a location maybe in Bangladesh, right? First, then we go for it is a location maybe in the center point somewhere in Dhaka, in one of the district. Now, Dhaka is a huge area, right?
Yes, sir.
Now, maybe you can say in a northern zone, then what?
Then
right?
Uttara, then sector. Yes, sir. And then the
Then
specific
how
area.
do you find Uttara? Because in this planet, this is a very specific value and point location you have. How do you identify that?
X-axis and Y-axis.
Exactly. You see that entire this identification process for anything, you have to come back to the mathematics, and you just have longitude and latitude. On basis of that, even the satellite is pointing out that exact location of you, and how precisely they can identify, isn't it? And which has been used in your mobile phone as well for location detector. So that pixel, why we need it? Because maybe your entire image has to be defined in such a pattern so that actually you can identify the every bit of that pixel, okay, every bit of that image, and that can be identified as a unit. We give it a name as a pixel, right? We have it actually. That feature in more discussion is coming, so you will be more clear about it. But I'm just concerned about defining the computer graphics. Like if you have a definitions in here, a visual representation and manipulation of pictorial data. If your brother is going in 5th standard of the school, and if he asks what is computer graphics, then how do you make him understand, right? It's a very difficult job. It's if you just give the reply of in the interview board is not actually the sufficient understanding. So if you can make them understand that, then it could be said like your concept is clear. So you can then actually try to make them understand with many way that look you what actually he is connected with, maybe a video game, so that you, from there you can actually try to make them understand. And now how it is changing, it's very difficult to on the manipulation of the data, and because that is related with your actually programming or maybe help of the graphic hardware as well. So that type of a way actually you should try to explain of your definition. Okay, so I hope that this is fine.
Yes.
We go for some characteristics to discuss. The graphics consist of, this is a very too important concept for computer graphics that you need to actually think. One is actually your graphics all point addressing is actually a very important concept for the graphics, and another one is real-time method. So these two important aspects. One is all point addressable graphics and real-time method. Now, what is that all point? That is actually, you may think that addressing all point. I already mentioned, just give you hint in the previous slide when we were discussing about location of Uttara, right? So that you can see that in your entire image that you have to identify somehow all the point of it, and then actually you define or address or give value on basis of that you can actually identify the image. So that whenever we are talking about the art of drawing items on the basic output devices such as display screen by means of addressing different parts of the display. Okay, so that if you consider in a graph paper, I gave you a graph paper and I'm asking you, okay, can you please write down a big 1 on that? So that what you're gonna do, you definitely try to write a 1, but whenever you will write 1 or maybe you make a shape of 1, you can find that it will fill up maybe some of the small boxes as a black color, so like you are doing that with a pencil, and the rest of them are maybe blank. Only for that reason you can see that there is a shape of 1. That means what actually end of the day you are doing, this entire screen, if I consider that entire screen is actually having a small boxes, and just quickly go for you can see the whiteboard.
Yes, sir.
Okay, so if we just consider that what actually we do understand about all point addressing, so like I have a screen, and the screen has been defined with small boxes, and I usually, according to the pixel that the discussion we had earlier, this is the way actually all the image is generated on your all digital screen. So that's why you have that megapixel, right? That actually capability for the camera that you actually define. As you know that that value comes actually from this vertical and horizontal lines created. How many boxes on your image is actually shows the capability for it. So if we consider how to fill up that, that is line, and if we go for anything, say like if I have I want to actually draw a line. What I can do actually say like fill up this box, this one, a straight line maybe. So if we have millions of pixels on a screen and we randomly actually use the value, say like I'm actually using the value for these pixel addresses, all these pixels definitely have some specific addresses, because this area is now actually identified with that as same like in the Earth we have done like a longitude and latitude, so that this is the way that X and Y axis that we can identify the some value or location address of this pixel. Now in my programming, or maybe in the instruction to the computer, that I'm saying this specific of those pixels are having different values, say like the value for red and the rest are actually the value for white. Then whenever it will be actually pop up on the screen, you can see a line there, because as we are actually almost zoom out, so that's why you can see those boxes, but you cannot see actually the boxes. Like you can see the line here. This is actually many of those numbers are actually defined with the red color value, so that's why actually you can see it at the very beginning. All of them are as a white background, so that all of them are actually having the value for the white. Now this has been actually changed, right? So what end of the day you are doing, all point of the image you have been addressed with some value. Okay, so this is actually the most fundamental concept for the computer graphics that we can say. So drawing the items on the basic output devices that were actually you show, such as display scheme, by means of addressing the different parts of the display, so that different part of the display. Here we can see that it's a black color, those fonts, those specific point values are actually in the values for the black color, so that actually it creates that shape. The rest are actually the white color, so that's why you can see it, right? So that is actually the most important concept for the all point addressable graphics. Okay, and real-time method is actually more like an interactivity, as what happened instantly, that is actually the case, and it involves getting the CPU respond to user immediately, so that you are as an user actually whenever you are giving an instruction, the processor is actually responding immediately. That actually create a sense of real-time activity. Now this can be actually depends upon, you see that this is also actually kind of a senses that as a human can gauge, like somehow if your processor is very slow, so that you are giving an instruction and it takes at least 2 seconds maybe to respond. So 2 seconds is a huge time actually. For our understanding, maybe we can identify, but it is all goes in actually millisecond or microsecond that level. So whenever this time difference are actually short, then we find that is actually real time, it's happening. Okay, but nothing happens in the real time, isn't it? Because every fraction of a second we moves forward. So whenever you give command, it takes actually some time to reach and to react by the machine. Still it is in the future, but we don't feel it, because this is actually also our brain sensors have some actually what is called that limitation in that sense. And user entering the information, the computer replying on the display within tolerable time. That's why actually it says tolerable, right? So that if it is taking a long time, then actually it will not work. What happens in your game as well, that when you are going to play a video game, that has to be instantly actually reacted, otherwise you cannot play. Or maybe it is, or in some cases it has to be in such a way that if you feel like that it is happening instantly, whatever it is actually. So that's why you may have actually high power graphics hardware for it to support. That means the machine need to support for the process, an extra processor you need it. So the example like graphs, pie charts, histogram, those are actually for information graphics when you give the data so that it can be pop out, or model trained video games, multimedia, and so on. So those are actually the real-time activities. So these two concepts are important for the graphics. One is actually all point addressable graphics. We're addressing all the points of an image related with the pixel, and another one is actually the instant activity with the real-time responding. Okay, so that's two concepts are actually very important. So in any point, if it is asked like computer graphics, what actually a computer graphics actually what is called the characteristics you may have, or what actually computer graphics should or must have, that maybe you can define. Okay, so let us go for the classification. You can see here that in this chapter we try to discuss about computer graphics, the preliminary discussion about the graphics, what it is, try to understand it, then we go for classification, and then we'll go for actually application area. Okay, so if we go for types of graphics, they have been actually classified in two types: raster graphics and vector graphics. Now this classification is done on basis of actually the image processing technique, how the image can be created on the screen. On the basis of that, we can classify the computer graphics in two types. One is raster graphics and vector graphics. We try to define another classification, that is we call actually that on the basis of using the computer graphics, the graphics usability. That is, one is called the interactive graphics, another one is called the non-interactive graphics. Okay, so these are actually the two way, on basis of two way that we are going to classify the computer graphics. So if we go for the first one, like types of computer graphics, for image generation technique, we said raster graphics and vector graphics. Now, whatever the discussion we have done about computer graphics for image generation actually process, you can see that we also actually show with addressing all the pixel or points. That is actually the raster graphics, where each pixel is separately defined. And while in vector graphics, that is slightly different. The image you can find, those are actually generated using the vector. Okay, and we know that vector is a mathematical element, and for mathematical element is what, which is actually having a direction for that vector. So we use many different mathematical formulas to draw the line and shapes, which then actually interpreted at the viewer side to produce the graphic image. So as you know that those line and shape also can create actually an image. Okay, now that these vector graphics are actually can be magnified infinitely without loss of quality, as they are not actually the pixel based, as you can see. So you can understand this image is actually the vector graphics. You need actually a different device for it, for the display is a vector devices. Okay, and it's not very common. So and it also have many issues, even though the quality of the image, if you magnify, you can see there on the top, they never break up. But if it is go for raster graphics, the digital image that you do, they do break up. Now, why then actually we do use raster graphics? 99% of the devices in the world are actually all raster graphics. Very few, maybe in some special actually purpose or for this spatial reason, some device may have vector devices. Now, what can be the common approach for it? Because raster graphics are easy to generate, the first of all. The second thing is, if you want to create actually a shade, a real life image, then it's very difficult for vector graphics. Because light shade, it is difficult to handle with the mathematical formulas. Rather than the raster graphics are actually defining the pixels, so that maybe you go for actually huge number of pixel or for image and define all of those position according to different colors, so that actually you can create a very real life image. So from that actually application or perspective, that raster graphics become actually taken all the digital display or the image. So that computer graphics mostly we do understand based on the raster graphics, but there is another type which is we call the vector graphics. If we go for more detail in raster graphics, It is called the dot matrix data structure. Why it is called dot matrix? You have already seen that when I have drawn that x and y axis coordinates, all those lines, they create actually small boxes are in a matrix shape in the dot. Okay, that's why it's called the dot matrix data structure, representing generally the rectangular grid of pixels. It's a points of color, as you can already have seen. Those small pixels are actually defined with some color. Okay, viewable by monitor paper, other is by medium, that is the raster graphics is, and they are stored in image file with very format, different format they can be set as an image file. And this is technically characterized by the width and height of the image in pixel. So you have seen that already how many lines you have in the x coordinate and y coordinate. That actually gives that many number of pixel. Okay, and also the number of bits per pixel. Now, what is bit? Who can tell that what is bit?
Sir, there is a relation between bit and byte 1 into 8, 1 equal to 8.
Okay, that is relationship between bit and byte, but I said what is bit?
A small
If you
piece of quantity of something.
sorry, say it again, I missed it. Small? Yes, in hertz, right?
It is
Someone.
the most basic unit of information in
Yes,
computer
basic
and
unit of
digital
information.
communications.
How computer have information? Computer is a machine only.
Which can 0 and 1.
0 and 1, sir, bit.
0 and 1, I do understand it's actually the number. Like 0 to 9 that we have, right?
So not information, it will be data.
Okay, data is actually another way to say about information.
Sir, bit is the small part of anything.
The definition you have given, Alamin, that is actually a language definition. Okay, that means contextual definition. I said like my problems I have actually distributed in small bits to all my friends, so I have something. So that is actually the meaning of the bit. I said what is bit, as we are talking about computer, right?
Full
Yes,
from a
Minhaj?
bit. Full from a bit is binary digit. Combine,
This is not good. Okay, you
Sir,
see that
bit
that's
is
why I've said.
Unit of data
is short of
in a
binary
computer.
digit.
Does those block you mentioned, is those block called bit for graphics?
The block you are talking about.
Yes, sir.
No, that block can be. You can see here that every image have that actually small block, right?
Yes,
The small boxes that we are calling pixel. Now I'm talking about whenever you think about those small boxes and about the image, then definitely always will try to define them as a pixel. That they do. But I said, what is actually bit?
bit is the smallest unit of information in computer.
Smallest
No, that
unit
is.
of data.
I think it's based on time. How much pixels we are seeing in a certain time is related with this.
But I know, Iram, that you will also agree that the unit of time is actually second, isn't it? Or maybe furthermore fraction you can go, but not the bit.
Sir, bit can hold a 0 or 1. It is a binary digit.
That is true. Whatever all of you are saying, all are true, but you are not defining the bit. Right? If I say like Iram, that someone can say he's a singer, someone can say he can miss the first class but come in the second class, or maybe someone say he's very friendly. Like all these are true, but at the end of the day, he's a human being, isn't it? His first identification. So many of you are saying whatever all are correct. But that is not the answer. You are saying that 0 and 1. 0 and 1 is actually, yes.
Sir, here it will be the
Yes, Charmin, yes.
sir, here it will be the unit of time. Per pixel, it means per 1 second. So I'm sorry.
No, it is not. Unit of time is, look, the unit have not been changed in the world, right? So whenever you say unit of something, that must be for something. Now bit is definitely unit of something that all of you are missing. You are saying about
bit is a measurement using the
Atik
quantify
Faisal.
computer.
Yes.
This is
I am not accepting the actually term data here. Okay, data
unit
is
of
different.
information.
Yes, unit of information. Information same as like actually data. Computer is a dumb device. We all know, right? It is only a device. You just play with many signals with this machine. And we have gone in such an intelligent level now with this machine. Now you feel like it is almost like your companion. Like every time you're giving something, it's returning back. You see information, processing it, working on it, and so on. But what actually it is doing? It must have some memory, okay? And that memory unit is actually bit. How do you miss all of you, right?
I told you, sir, storage memory.
Yeah, okay. That's why I just somehow storage that what I heard, but I could not. I just missed it because many of you, I was calling your name. That's why, because that is actually not the unit of the information. Information is nothing, just process of some of the data which is stored in the memory, and they are coming according to your wish, so that you get some information from there. Okay. So, but at the end of the day, the bit is actually the unit of the memory. You can see that every pixel, that the small boxes that we have said, they have a relationship with the memory. And that's why actually we can call it like a color depth. Just consider this image. It's saying on the top raster graphics, all are in black color, right? Say like this small, all these pixels are actually having some specific address of those pixels. Say like I'm saying here, this one is 57, 58, 59, like this way it is going. Then again, that part is actually having maybe 60, 61, 60, like on the top, those are white. But before 57, 56, like coming back, so like 257, the next line is actually having again the black color. Now, entire of these few thousands of those pixels, few of the pixels are actually defined with different color value as it is black. Now, how it will be stored? Definitely, you need to have some place where actually these pixel information are stored. Now you see that the information or data, that term is coming. Now, those are actually stored in some specific area of the memory, and that has been defined with the unit of the memory that we are calling the bit. Okay, so that's why in raster graphics, by the number of bits per pixel, okay, so every pixel with that small number of bits, that is called the depth of the color. That term we will go through later, which determines the number of colors it can represent. So if we go for in more detail, you see in the raster graphics, in one bit, one pixel has been, you can see here that it has been distributed in here with that red, green, and blue, and that actually combined the color as well. Okay, so in red, green, and blue here we can see not one pixel, 3 pixel in the level when we actually zoom in, or that is magnified. Then we can see here that which we are calling the kind of white color, isn't it? That red is actually having 93%, green is 93%, blue is 93%. You see, these are actually primary color. We all know RGB, which having highest value, then it is actually the white. As you know that the sunlight as well, that all the color spectrum that we have are in the highest color. So whenever something is missing, that actually you see in the object falling, and that object actually take that colors, and which is missing that they reflect that color you can see. So if you wear a blue shirt, actually that shirt is blue color is missing, all other colors are there, so that's why you can see blue color. This is very interesting part of the physics with the light and color. So at this moment, this is actually on this digital screen we are talking about, this pixel level that has a different value of the color for this one, and this information, these values, what it should be, are stored in some part of the memory. So that is actually every pixel is related with the bit value. So that will give actually the depth of the color as well. So this is actually the part of the raster graphics. We are trying to understand raster graphics with this pixel-based graphics or dot matrix graphics that we call. So this smiley face in the top left corner is a raster image, and when it is enlarged, as you can see, that small individual pixel can be appeared here as a square, and with some different value can be said. You can see red and green combined actually creating the yellow color. So 90% there, so blue is missing, so that you can see that yellow color. Okay. And zooming in further, they can be analyzed with the colors constructed by adding the values for red, green, and blue. So these three combination create actually huge number of colors. Now there are actually how it can be actually more number of color, millions of color. And also interestingly, you will come later as well, human eye also, as a human, we also have a limitation. We cannot see after certain combination of color, we cannot see the other color. Maybe another animal can see. You never know. Okay, so that this is interesting. That color is also few thousands, I think, combination. Even you can hardly identify the difference between one color to another color. So this is about the raster graphics. Let us move on. What is the time? Okay, the vector graphics. If we go, already we have said about this is actually geometrical primitives, like we use it, point, line, curve. Why it is called primitives? Because these are the primary element. As you know, that point can create actually the line, right? If we take a line can create maybe a rectangle, right? Or curve and shapes or polygons and so on. All of these are based on mathematical expression to represent the image in computer graphics. In vector graphics are based on vectors, also called the paths, which lead through the location called control points and nodes. So from one point to another point that we can actually move on to draw it. So if we go for that page that we are drawing that time. So if it is actually raster graphics concern, if we think about the vector graphics, then actually the same screen that we have, and from there maybe you are saying that a node or point from any specific one, say like V1, to that go to the line up to V2 location, and that is actually created that line. So this is the line in the raster graphics that you can see. This is the way the vector graphics you can see. Here the main concern is actually from node or point to point, that you have some instruction in the mathematical formula to draw that one, okay, so that it can be created. So that's why if we just enlarge this image, then actually they do breakdown. As you can see that if you zoom any image in your mobile phone as well, any image, after a certain point it actually breaks down, because it also has a limitation for that. But for our experience of an image, that is sufficient. Now a huge number of pixels can be defined. As much number of pixels you have, as much your quality of the picture actually get high. And if we consider for actually vector graphics, here you can see that node point to node point, that if you have a vector movement, okay, or the line, so that actually you can see the line here. So for vector graphics, each of these points has a definite position on the x and y axis of the work plane and determines the direction of the path. So any node or point, what you can get the values for x and y, and then actually you can identify that point and can draw. So for example, say like this H has been drawn. As you can see that the outline has been drawn first with those small nodes, and they have been used actually the cubic, that is line curves, for Bezier, for that this point to this point, that curve they have been drawn first, then actually they fill up the color maybe, and that you can see that as a vector graphics. If we go for raster and vector, that you can see there are many formats like JPEG, .jpg, PNG, common format for that image that we know. What can be actually formation from here? You have some idea that if we zoom in, it is a small pixel can be said for the raster graphics. For in the vector, if you zoom or maybe enlarge the image, the quality does not break down. If it is enlarged, like the vector, that format is SVG, and you can find the difference on there. Now, still, why actually, again, you may feel always like the quality, if it is an issue, then why we do not go for vector? But because you need actually different display system, different processor, and also it is not necessary, as long as you can actually work very easily with the raster graphic system, where all are actually digital pixel, the value you define, and easily you can actually generate an image, and also a high quality you can create. The basic difference between these two is actually, if you want to go for real life image or shape to see, it's not possible with the vector graphics, because the color also have limitation there. Okay, so there are some certain reason for these raster graphics are actually grabbing all the digital screens market. And in another way, now if we want to classify, we said like that will be actually defined on basis of the usability of the computer graphics, how we can use it as a user points of view. From that, we can actually classify the graphics here. So we are saying that interactive graphics and non-interactive graphics. And we all know interactive graphics are actually what? User have some control over the picture. That means whatever you can see on the screen, you can change it. Okay, so you can change that in the produced image. So interactive graphics involves in a two-way communication between the computer and user. So you are doing some instruction, and on basis of that, the screen is changing its image. Here the observer is given some control over the image by providing him or with an input device, through a device that you can do it. For example, the video game controller of the ping pong game. Say like you are playing a game and you are actually trying to stroke a ball, and that ball is actually hitting another one. So what is happening? According to your input with the device, that it has been changed the image on the screen. So that's actually the sending the signal to the request to the computer. Then computer or processor receive that signal and from the input device and can modify the display picture appropriately. If it is cannot, then actually there's a problem. Now you see that this activity is a very stressful activity for the processor, because whenever you want to change something on the screen, and you can see that it has been instantly happening, so they have to react very fast. Okay, so that's why they need sometimes the extra support. So that graphics adapter that you actually try to put, sometimes you put extra RAM for memory processing instantly, so that's actually you need to do it. So many video games, that's why you need actually the extra that what is called configuration for it. The example for interactive graphics, already we said about video games, is a very good example. We also have some other actually, which is heavily used, like simulation software for training. So the user, it appears that the picture is changing instantaneously in response to the command. So you are actually giving a command and instantly it has been changing. Okay, and user can give the series of commands, each on generating a graphical response from the computer. So through your input device you are doing, but someone wrote the program for it, like every stroke that you are actually doing through your keyboard or mouse or maybe some other input devices, what actually the way the image could be changed. Okay, so that's instantly it has to be actually identified, and this way the user maintains a conversation or a communication with the computer. So you can see that whenever you are playing, you somehow are actually in that activity, you are involved. So you and computer is actually doing that interactivity, or like a conversation that we are saying. Like simulation software helps to train the pilots of airplane. So this is definitely, you want to be a pilot, so no one will give you a plane to actually start flying, right? It is not like so easy. So that's why they give, actually take you to a actually simulation software. What is actually happens when you all of your machineries that actually you give a value or change the value or switch on or switch off or actually tune the values, all are all input devices and input actually command that you are giving. On basis of that, you have a screen where actually you can see a real life activity that has been happening, will feel like real life, so that you will be trained up that how you may feel in actually really when you are going for flying a plane. So that's actually the training software. These are very important one, and the simulations, as we know. Like this example is XTS home flight training software program for the pilots. And in non-interactive graphics, we're going to finish in very soon. Non-interactive graphics, where exactly the opposite happens. That means actually the user does not have any control over the changes. Okay, just think about that not only the static images in your computer, rather than the changes you are happening that is not done by you. Say like when you are watching a movie, or maybe when you are actually showing the screensaver, you see that the screensaver, they instantly continuously they do change, but who actually changed it? It is changed by the processor itself with a stored program. That means actually it has been written already, the instruction that what it will be done. So these are actually the non-interactive graphics. And another way we can say, in another name, is passive computer graphics. When we are saying passive, that means it is not happening directly. It is done by actually some other way that we are calling actually done by the processor. Okay. So that's why it's known as passive computer graphics, in which the user does not have any kind of control over the image. And image is merely the product of static stored program and will work according to the instruction. So we said about watching movie. You cannot actually stop the movie and change the scenario of the movie according to your wish, right? Whatever the director has been actually filmed, and they have been actually put down in a file, that is static stored file that you can only see. Image is changing, the changes has been done by some other way. It is not by the user who is actually watching it. So that's why it's called the passive computer graphics. So the image is totally under the control of the program instruction, not under the user, as like a screensaver as well, that is done, right? Okay, so that's done for today that we have done. What actually we have done, we discussed about the computer graphics in details, the basic feature of the computer graphics that according to our understanding. Then we try to classify the computer graphics in two aspects. One aspect, or on the basis of the image generation technique, we said there are two types, raster graphics and vector graphics. Another way we have said that is actually according to the user's point of view, graphics can be classified into a interactive one and non-interactive one. If we go for raster graphics, we say this is nothing but actually our digital photograph that we define with the individual pixel in small boxes, the entire screen, and we put the value on basis of it, for the color value on basis of it, so the image can be created. While the vector graphics are actually using the mathematical formula, we use the vector, especially the geometrical primitives like line and points and so on, to create the shape. Okay. If we go for the feature of them, raster graphics can be breakdown if we enlarge, vector graphics are not. And if we go for interactive and non-interactive graphics, we can say that interactive graphics, the user has a control, as like in the video game, instantly they can actually change. You can see this is actually the hints of that real-time method for that interactive graphics. And this is actually more like focusing on the raster graphics, that the feature. and non-interactive, where the user have no control over the changes of the image. Image is changing in both cases. Okay, interactive, non-interactive, both image is changing. One actually user has a control, another one is actually user does not have any control. So that's why it's called the passive computer graphics, right? Okay. So do you have any question, anyone?
Sir, up to this it's okay, but about the question bit, somehow I found later that like if we consider 1-bit machine, that means 2 to the power 1, so we can represent only 2 color, like black and white. Before the using of Windows X, XP, we are using 2000, so there mostly we found the black and white devices. That means their bit was very low. Is
That I have used as well. My first monitor was actually I bought in 1999 maybe, and that was a black and white monitor. And we used to actually work with there was actually many story about how the computer has been changed up to this level. Yeah, that we have another in chapter is all this definition that is called the color depth. Okay, that whatever you are said, 2 to the power n. You will see that there will be more discussion about that. At this moment, the bit is actually, you need to understand. You see that this is the problem. If you want to be an engineer, your concept has to be from the very fundamental level, not like the application level, because application level can be used by technician, not the engineer. Now, bit is, your first thing is the memory. You see that whenever you are defined for any image, without memory, can you think that the machine can work? Maybe not. It can work, it can do some certain things that doesn't need any memory. But why the computer becomes so dynamic? Because it has memory. It has like a human as like you, so that you see that as a robot don't have any memory, so that you just give an instruction, it is instantly do it, like moving or something. Still you need actually memory, because you need to write down all the programs and store it. But if you have actually a memory with a dynamic manner, then your machine processing will be more dynamic, right? So bit we are talking about actually that in that perspective from the memory unit. The unit of the memory is called the bit. The byte is actually when you go for in a 8 number of bit, in another name is byte, right?
Yes.
So that's the relationship that we can do. If we say like data and information, all data and information need to be stored, and we call it like when it is coming by from the memory to your display screen. As long as it is not coming in the display screen, you cannot actually experience it, isn't it? And that's all the information what we stored in the computer doesn't make any sense if you cannot see it. Okay, all right, thank you very much. We will start the next class with some pre-discussion maybe about whatever the few points we have discussed today. I do expect that you will actually go through. If you just the slide you will get maybe on the next day, but at this moment, whatever the point we have discussed, I hope that I requested. I know that in the early morning it would be difficult maybe because you are in not in a position maybe all the time that listening the lectures carefully, but try to put down some point, try to write down at least 2-3 lines, so that actually you can think at one point of the day before coming in the